Hello, coming to you through the magic of the internet. This is Mr. Bauer with Vector Math Quest questions number 23 and 24. So the statement of the problem says that this knot is in equilibrium. And right off the bat, I just want to make sure you understand that when you see that word equilibrium, it means the forces are balanced. In other words, in this situation, these forces add up to zero. Now, you can literally write an equation there. Let's call this one force A, this one force B, this one force C, and our unknown we will call force D. So literally that means force A plus force B plus force C plus force D equals zero. And these, of course, are all vectors. And then we're trying to find force D. So just like any other algebra equation, we can solve for force D. And this shows us ultimately what we have to do to figure out the answer to this question. We have to take negative force A minus force B minus force C. Now you can jump into the math, but I always like to draw a diagram first. You can literally draw a vector diagram of this equation. And I would like to do that. So I'm going to start by drawing negative force A. That just means drawing force A in the opposite direction. I'm just drawing a little origin here so I can measure a 40-degree angle in the opposite direction. So this is my 40 degrees. It is the exact opposite direction of that 40 degrees. And this is supposed to be 6.5 newtons. So that's negative force A. Now from this point right here, maybe I'll draw another origin so I can measure my next angle. I need to do negative force B. Force B is a 51-degree angle down there. So I need to do a 51-degree angle up here. Notice that this angle is exactly the opposite direction of that angle right there. That's supposed to be 5.2 newtons long, so it should be shorter than the one I just drew. And then finally, from here, I'm going to draw negative force C. So I need to do a 39-degree angle in that direction, 39 degrees, because it's the opposite of this 39-degree angle. And that's also 6.5 newtons, so about that long right there. So that's minus force A, minus force B, minus force C. Your answer vector is always going to be from where you started out to where you ended. So this should be force D. And you can see that that matches the way they drew it in this diagram here. And so we're looking for our answer to be in the first quadrant, have a positive X component and a positive Y component. So now let's get into it. You might remember the only way to add vectors mathematically is if you can add X's together, you can add Y's together, you can add an X to a Y, but they have to be in X and Y components. So we're just going to have to take all three of these vectors one at a time and find their X and Y components. I'm going to start with vector force A. I'm just going to draw it all by itself so it's not confusing. It has a magnitude of 6.5 newtons. I'm going to drop a perpendicular down to the x-axis so I can see how long its x component is, how long its y component is. I can see that the x component is adjacent to the angle. I'm going to use cosine. Cosine of 40 equals adjacent over 6.5 newtons. I'm not going to show all the algebra, but if you solve for adjacent there, you should get 4.98 newtons. One additional factor though, since it points to the left, it's negative, and that's important. Likewise, if you take a look at the y component, it's opposite the angle. So we're going to use sine. Sine of 40 is equal to opposite over 6.5. If you do the algebra, you should find that the opposite side is equal to 4.18 newtons. And since it points up, it's positive. Now I'm going to put this in IJ notation. You don't have to do that, but I will. So that's negative 4.98I plus 4.18J newtons. So now I have to do the same thing with the other two forces. Let's go to force B. So let me draw that down here. I'll draw force B, and that's a 51-degree angle. Hypotenuse 5.2 newtons. If I drop my perpendicular to the x-axis, there's my x component, there's my y component. X component is opposite, y component is adjacent. Sorry, that was totally wrong. Forgive me. X component is adjacent to the 51-degree angle. Y component is opposite the 51-degree angle. So again, for the x component, I'm going to do cosine. Cosine of 51 equals adjacent over 5.2, and the sine of 51 equals opposite over 5.2. When you calculate those, I'm going to write it right into the ij component. You should find that your adjacent, the x, was 3.27, but it points to the left, so it's negative. Likewise, your opposite, I came up with 4.04, it points down, so it's negative. So there's my ij notation for force B. And finally, of course, we have force C, 6.5 at a 39-degree angle. Maybe I'll do that here. So there's my 39-degree angle, a hypotenuse of 6.5 newtons. I'm going to drop my perpendicular. My x looks like this, my y looks like that. Again, x is adjacent, y is opposite. So similar formulas, cosine of 39 equals adjacent over 6.5, and sine of 39 equals opposite over 6.5. When I do that math on my calculator, I get an x component of 5.05, and that's positive because it points to the right, and a y component of 4.09, and that's negative because it points down. Okay, now we have to take those vectors and put them into this formula we figured out, that force D is equal to negative force A minus force B minus force C. And so I'm going to write that whole thing out with the I's and the J's. So force A is negative 4.98 I plus 4.18 J minus force B is negative 3.27 I minus 4.04 J minus force C is positive 5.05 I minus 4.09 J. Now, we just have to combine like terms. And don't forget your negative sign. So negative, negative, that gives us positive 4.98 I. I'm going over to the next I. Negative, negative gives us positive 3.27 I. And over here, negative, positive is negative 5.05 I. Those are all the I's. And then what about all the J's? Negative, that is negative 4.18 J. Negative, negative is positive 4.04 J, and negative, negative is positive 4.09 J. Now, if I add all of the I's together, all of the X's together, I get a total of positive 3.20 I. And if I add all of the J's together, the Y's, I get a total of positive 3.95 J. And that's for force D. Now this looks good because it has a positive X and a positive Y. And when we drew our picture, that's exactly what we thought we were going to get. So our final step is now to go from unit vector notation back into magnitude and a direction. I like to draw a picture. So I always draw the X first. That's just my habit. So positive 3.2 I. And then from the tip of that, I'm going to draw my Y a little bit longer, positive 3.95 J. Be a clear J there. I didn't make it very clear earlier. And then my result, nice magic colors for my result, my magnitude, and my direction. So we can use the Pythagorean theorem formula to figure out the magnitude. I've got 3.20 squared plus 3.95 squared, and that gives me a total of 5.08 newtons. That's the magnitude. That's actually the answer to question number 23. And then I believe 24 asks about the direction. So I'm going to do the inverse tangent, opposite this angle, 3.95. Adjacent to this angle, 3.2. When I do that on my calculator, I get an angle of 50.99 degrees, and that's what they're looking for. If this was a test or a quiz, it would probably be best to say 50.99 degrees above the positive X axis. So hopefully that made things clearer for you. Good luck with that problem.